Okay, 45. Alligator bites. People bitten by alligators in Florida over the last 36 years. Well, 72 2007 anyway. Make two graphs to illustrate why you should make a time plot for data collected over time. Make a histogram of the counts of people bitten by alligators. Distribution has an irregular shape. What is the midpoint of the yearly counts? Well, the first thing to remember is there's 36 pieces of data, and when I put this in my calculator and I want to make 7 different classes, I ended up going from, I'm looking at my calculator now, I'm going to put counts on this side. I ended up going from 0, 2, 4, 6, 8. I take that back. What am I thinking? I went 4s, 8, 12, 16, 20, 24, 28. And the reason I chose that, I went by 4s, is because I noticed the maximum was 25, and the minimum was way down here. At 1 year there was 3, and so I thought, well, if I went from 3 to 25, if I started at 0 and I went up to just over 25 and I went up to 28, if I divided by 4, I could have even numbers of classes, and that would give me 7 classes. There's different ways to do that. I could have actually done and started and gone 25 minus 3 is 22, and divided that by 7, and that would have been 3 and some change. 22 divided by 7, it said 3.1, and made my classes 4. That, if I rounded up to the next whole number, that would have been 4, and I could have started at 3 and gone 3, but this way I get a little bit on each side, and that's fine. There's no set, you have to do it this way, every single time, or things, of that nature. So I've got my histogram looking like this, and I look at my scales here. I'm on my calculator, and I'm just seeing how should I make my Y scale so that I can visualize it the best. And so I'm actually gonna use these boxes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 10. So this is counts. Always label everything. So from 0 to 4, I've got 3. So I've got 3, and then I've got 7, and then I just kind of go along the way here. 5, and then 7, 7. The next 2 are 7s. And 5. Now, what do I have to do if I'm going to give you a test on this and I want all of yours to look exactly the same? This is down here at 1. I would have to tell you, start your histogram at a certain point and make your class widths a certain width or something of that nature, which I'm more likely to say, hey, make a good solid histogram, and then I'll just I'll check your numbers and make sure they're good. So there's my histogram. I need to tell you what these are. What are these counts on the bottom? These are alligator bites. Key thing, I'm going to be looking at labels, making sure you label both the axes. I'm going to be looking at your scales. Do you have scales on both sides? And then, of course, I'm going to be looking at your data. Okay, so there's A. Make a time plot. Oh, by the way, it says irregular shape. Yeah, this is what's called uniform. I'm going to change colors here so you can see. Fairly uniform because it's fairly straight across. I mean, it tails off at the end, but that's just because I have only one piece of data in this from 24 to 28, but it's fairly straight across. That's called a uniform distribution. Okay, B, make a time plot. So we want to go from 72 to 2007. There's 36 pieces of data on here. So if I go across here, and I'm going to go from, what we say, 72 to '07, right? Oops. 72 will be this guy right here. 73, 74, 75, 76. I'm going to make this bigger. 77, 78, 79, 80, 81, 82, 83, 84, 85, 6, 7, 8, 9, 90. Yeah, a little bit tedious. 1, 2, 3, 4, 5. But much more enlightening than that histogram. 9, 2000, 2, 3, 4, 5, and then '07. And then on the vertical axis, it's going to be actually the number of alligator bitten each year, and it's going to go up to 25 is the max. So let's do something like this. Um, what if we did this? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So 2, 4, 6, 18. And just do it like that. Okay, so I'm going to shrink it down here so I can see the data. And I'm going to draw that in a different color even. Let's do it in green, say. Make it a little bigger. Okay. All right, so we got 4. So I said 72 is here, so we got 4, 3. Oops. So I'll tell you what, I'm going to pause it. I'm going to draw the graph because you don't need to watch me plot all the points, then I'll come right back. Okay, there we go. There's the time plot, and yes, the trend reflects Florida's growing population. Uh, kind of going up, upwards for sure. Okay, the question they asked though is how many of the 22 years from '86 to 2007 had more people bitten by alligators than the midpoint from A? Well, what's the midpoint from A? Well, we've got 36 people, so 18 would be the midpoint. So we're going to count up 18. So 3, there's 10. 15 plus 7 is 22. So the midpoint's going to be somewhere between my 5 and my 7. So somewhere right around 12 alligator bites, somewhere in that range, 12 alligator bites. So here's my midpoint, 12 alligator bites. So if I just kind of draw my line there and I say, well, how many years from '86 to 2007 had more people bitten by alligators? Well, from '86 to '07, here's '86 to '07. That's all of them but 2. How about that? That gives you a little different picture than the histogram. Because see, the histogram says half the people got more than 12 bites, half the years, and half the years got less. But here from '86, it's all of them but 2. So it tells a little bit different picture. So sometimes time graphs are definitely more valuable than histograms, and that's what we want you to recognize here. So it depends on what you're trying to see as to which graphs are more important. So there you have it.